Okay, so now we're in section 2.2, which is all talking about the GCF, which GCF stands for greatest common factor. So let's talk about some vocabulary before we dive in. Okay, so let's look at the definition for a factor. A factor or factors are numbers when multiplied together give you a new number. So they're numbers that multiply together to give you a new one, to give new number. So they're numbers that are multiplied together that give you a new number. Okay, and you may be thinking, what exactly does that mean? So let's look at the number 6 for a minute. What numbers, when multiplied together, give us 6? Okay, so you may be thinking, oh, 3 and 2. Are there anything else? Anything else that multiplies together to give us 6? Hopefully you're thinking 1 and 6. Okay, so we just listed out our factors. Our factors are in red. And what we would do to find the greatest common factor is we're going to compare two numbers and compare their factors and figure out what's the greatest number they have in common. Okay, so, but in order to make that simpler, we're going to put these factors in numerical order. So I want you to write your factors later on in numerical order, such as 1, 2, 3, 6. Okay, so that way, when we're looking at a whole bunch of numbers, it's a lot easier to see what the greatest factor is. Okay, so let's talk a little bit more. I've kind of said what greatest common factor is, but let's talk about it a little bit more. So it's when we're comparing numbers. So when comparing numbers, it's the greatest number that they have in common. Greatest factor, the numbers have in common. Sorry, I wrote a little tiny. I was running out of room because I zoomed in too far. Okay, so when comparing numbers, you want to find the GCF, or the greatest common factor. You list out all the factors and figure out which one they have in common. So again, in order to find the GCF, our first thing is to list out all of the factors. So list out all the factors of each number. And then once we list them all out, then we can circle which one they have in common. But not just circle the one thing they have in common, but circle the greatest number. So we want to circle the greatest number they have in common. Okay, so let's look at 8 and 14. So I'm going to write them out. I'm going to write 8 here, and I'm going to write 14 here. And I want to find factors of 8. Things that, when multiplied together, give us 8. So I know it's 1 and 8. And I know 2 and 4. Is there anything else? Anything else that we could think of? No. So it's 1, 2, 4, and 8. Okay. So again, we want to write these in numerical order. So we don't want to write them in any random order or as you think of them. So I would start with 1 and then I would go to 8, or I would just go 1, 2, 3 and figure out. If you don't know the factors of some of these numbers, because some of the numbers have a lot of numbers in common, a lot of factors in common, or just a lot of factors in general. Since you guys can use calculators, now would be a good time to bust those out and just start dividing them by 1, 2, 3, 4, so on and so forth. Okay. So now we have the list of factors of 14. I know there's 1 and 14. And I know there's 2 and 7. I'm trying to think of anything else. I know 3 doesn't go into it, 4 doesn't go into it, 5 doesn't, 6 doesn't, and now we're back at 7. So these are my factors. So now I'm thinking, what do they have in common? Well, they have 1 in common. They have 2 in common. They don't have 4 or 7 or 8 or 14. So now they have 1 and 2 in common. But we wanted to find the greatest common factor. So the greatest number they have in common is going to be 2. So we're going to write out that the GCF is 2. And that's what you have to write. So you can't just write 2 down. You have to write GCF is 2. Okay. So let's do one more together. Let's do 20 and 24. Okay, then you're going to try example 2 and example 3 on your own. So again, I'm going to put 20 up here and 24 down here. And I'm going to think, I know 1 goes into 20. I know 2 goes into 20. 3 doesn't go into 20. But I know 4 goes into 20. 4 times what gives me 20? 4 times 5. So since these two numbers are right next to each other in chronological order, then I know I'm not looking for anything really higher. I just have to find what's 20. 2 and what give me 20? 2 and 10. And then 1 and what gives me 20? 1 and 20. Okay, so just kind of brainstorming how I do it. Or you could also do what I showed before, where we know 1 and 24 go into 24. I know 2 and 12 go into 24. I know 3 and 8. I know 4 and 6. And 5 doesn't. So now we want to circle anything they have in common. They have 1 in common. They have 2 in common. They don't have 3. They have 4. They don't have 5 or 10 or 20 or 6 or 8 or 12 or 24. So they have 1, 2, and 4 in common. So then my GCF is 4. So my GCF is 4. Okay, I want you to try example 2. I want you to try example 2. After you try example 2, try example 3. The only difference is now we're comparing 3 numbers instead of 2. So I want you to try 2 and then example 3, and stop after that and we'll do 4 together. Okay, so for number 2, you should have had that they had 4 numbers in common. They had 1, 2, 4, and 8 in common, but 8 is the greatest one, so their GCF is 8. So you have to be really careful that you get all of the factors, because if you miss one factor, then you might miss the GCF. So I feel like a lot of you stopped after 4, but it does go up to 8. The GCF for example 3 is 3. Okay, so you're comparing all 3 of those numbers, 24, 30, and 45, and it has to be something they all share. So they all should have shared 1 and 3. So 3 was our GCF. Okay, so looking at example 4, we have some things thrown in the mix here. We have some variables, okay? So let's just find the number GCF first. So my number GCF, I would do 3, 9, and 12. Okay, factors of 3, 1, and 3. Factors of 9, 1, 9, 3, and 3. Since it's double, I'm only going to write it once. Okay, factors of 12, 1, 12, 2, 6, 3, and 4. And then what do they all share? They all share 1s and 3s. So then my GCF is 3. So my GCF, at least the number, is 3. But now let's look at the variables. So looking at the variables, we can write our own table for this one. So looking at the variables, I'm just going to write out what they have. So it's x, y. We have an x and an x, right? So x, y, x, and x. So what do they all have in common? They all have x in common. All three of these share one x in common. So that's going to be part of my GCF. So my GCF is 3x. Okay. So now that we found the GCF of individual terms, we want to find the GCF of an expression. So what we did in these first examples is just find the GCF of terms, but now we want to find the GCF of expressions. Okay, but before we do that, I want to refresh us on distributive. So I want you to try to solve this problem right here. So I want you to try to remember what you do when it looks like this. So take a moment and think about that. Okay, so hopefully you've thought about that a little bit and you distribute that 3 to both of those numbers. So it becomes 3x minus 12. So that's the distributive property. We're essentially going to be doing the opposite now. So we're going to take this portion and we're turning it in to what we would start with the distributive property. So we're taking the distributive property answer and finding the original problem. Okay, so let's talk about some steps. So we're going to be given an expression such as below, 2x minus 4. We want to find the GCF. So we want to find the GCF of each term. Okay, so let's find the GCF of really 2x and 4. So we're going to do our numbers separately and our variables separately. Okay, so our numbers, factors of 2, 1 and 2. Factors of 4 are 1 and 4 and 2 and 2. So it's just 2. And then our variables, one has an x and one doesn't. So it's just x and nothing. Okay, so what do they have in common? They have 1 in common. And they have 2 in common. And that's it. So my GCF is 2. And there is no variable because one has an x and one doesn't. So there's nothing they have in common. So my GCF is just 2. So now the next step is to divide everything by our GCF. Okay, so divide everything by the GCF. So I'm going to take this answer here, or this original problem, and I'm going to divide both 2x and 4 by 2. So I'm going to divide this by 2, and I'm going to divide this by 2. Okay, so 2x divided by 2, the 2's cancel out. So I'm left with an x. 4 divided by 2 is 2. And then I just bring this sign down. So now I am left with x minus 2. But that's not it. I have to put that in parentheses and put my GCF out front. So then my whole answer is this problem. So that's my whole answer. So I have my GCF and then what I get when I divide both of those things by my GCF. And that looks something like what we started with up here. So again, we're doing the opposite of distributive property. So this is really the opposite of distributing. Okay, so it's the opposite of the distributive property. All right, let's go to the next one. I want you to try example number 1 for me. So I want you to try example number 1. So you're going to find your GCF of both of them, divide both of them by your GCF, and then write your answer. Okay, so for example 1, you should have gotten 3 parentheses x plus 4. 3 parentheses x plus 4. Okay, and I did that by finding my GCF, which was 3. And then I divided both the 3x and the 12 by 3. Okay, I want to look at example number 2. Something a little different here. Okay, so my numbers are 10 and 22. Okay, that's fine. So I'm going to find my factors of both of them. So I know 10 is 1, 2, or 1 and 10, 5 and 2, and nothing else. And I know factors of 22 are 1 and 22, 2 and 11, and nothing else. So they have in common 2, and then one has an M, so the other one doesn't. So my GCF is 2. But it's not just 2. Hopefully you noticed that this 10M has a negative sign. Anytime you see a negative sign out front, our GCF is going to be negative. So anytime we have a negative here, our GCF is going to be negative. So now we're really dividing both sides by, or not both sides, both terms by a GCF of negative 2. So I'm dividing these both by negative 2. So then I have negative 10 divided by negative 2, which is a positive 5M. Then I have negative 22 divided by negative 2, which is a positive 11. I put these in parentheses. And then out front here comes my GCF of negative 2. So then this is my answer. Okay, so anytime you see that negative sign out front, make your GCF negative. So I want you to try example 3 right now. Okay, so hopefully you got negative 10, parentheses 3p minus 7. Negative 10, parentheses 3p minus 7.